Are you tired of manually walking Windows devices through all the initial first run setup steps? What if I told you there's a way you can automate the entire process using just a USB drive? In this video, I'll show you how to do it step by step. Today, I'm excited to conclude my 3-part series on automating Windows first run setup using a provisioning package. If you haven't already watched part 1 or 2 of this series, make sure to check them out, as I'll teach you what provisioning packages are and how to create one that can be used to fully automate the Windows first run setup. Now for this last video, we'll be focusing on how to test installing a provisioning package on both a virtual and a physical machine. Then I'll show you how to confirm everything configured within the package was properly applied to the device. And make sure to stick around until the very end, where I'll show you how to troubleshoot package installation issues, and we'll also highlight my overall tips and best practices for creating and using provisioning packages in a production environment. Okay, so to get started, we can test installing a provisioning package on either a virtual or a physical machine. Virtual machines are a great place to start, as they can be used to quickly smoke test the package to confirm it installs successfully. Now, there are a couple drawbacks with using virtual machines for testing, in that Hyper-V doesn't natively support wireless network adapters within the VM itself, so you're going to be unable to validate wireless network connectivity. And additionally, we also can't test Windows Autopilot because a virtual machine doesn't meet the necessary TPM requirements. But that's okay, as we can test both of these components using a physical machine, which I'll go over later. Before we get started with testing on a virtual machine, there is one extra step we need to do first, and that's to create an ISO image file that contains our provisioning package. The reason for this extra step is with Hyper-V, we can't directly attach USB storage devices to the virtual machine itself, but we can attach an ISO image file. I'll be using a PowerShell script written by Chris Wu to create our ISO file, and I've shared a link to this in the video description. While on GitHub, click the button on the right to copy the script in raw text. Then open up PowerShell ISE and confirm you have the Show Script pane enabled under the View tab. Here in the middle, I'll paste the script. To create an ISO file using this script, you need to execute the command in the following format. To keep things simple, I'll build and execute this at the bottom of the script pane so it's easier to follow along. For this first part, I need to provide the path to where my provisioning package.ppkg file is located. So I'll open up File Explorer and then copy the path to this directory. Paste the path into PowerShell ISE while also adding the package's file name followed by .ppkg, after which wrap the whole thing in quotes. Now we need to add the path to the directory where we want to save the ISO file. I'll use the same location and file name as before, but change the file's extension to .iso. To complete the command, type dir at the beginning, and then add the path to the .ppkg file. Follow this with a pipe, then the function new ISO file, with the path argument set to the ISO's save location. I'll then execute this by pressing the larger green arrow at the top. You can quickly verify the file was created by looking back at File Explorer, where you should see the new ISO file. Now, there are simpler ways to create an ISO file using third-party software with a GUI, but either way, once your package is inside an ISO, it's ready to be tested on a virtual machine. Firing up Hyper-V, I already have a Windows 11 VM set up and sitting at the out-of-box experience. While here, I'll go ahead and create a checkpoint so I can quickly revert back to this state later for additional package testing. Now let's attach the ISO file to the VM by clicking Media at the top of the console, then select DVD drive and Insert Drive. Then navigate to the ISO file and click Open. Press the Windows key 5 times to pull up the package install menu. If the menu doesn't show up, press Yes. Then try hitting the Windows key 5 times again where it should work. Once you have the menu pulled up, click Install Provisioning Package and hit Next. This package is configured to set the name of the PC, install 3 certificates, and then using provisioning commands, it's adding a wired network profile and then Entra ID joining the device. And now that our package is finished installing, we're greeted with the familiar Windows sign-in screen. All right, so now that we've successfully installed our package on the VM, let's confirm it properly applied our customizations to the system. Opening up a command prompt, I'll verify the PC name was set by running the command hostname. I configured the package to name the computer Contoso, followed by a hyphen and then 10 random characters. Next, let's double check that this was Entra ID joined by running dsreg cmd/status. Which looks good. Now to verify the wired network profile was added, I'll run a couple commands. Type in net start, and if you see the wired autoconfig listed near the bottom, this means the provisioning package successfully enabled the wired autoconfig.3 service. Then let's run netsh lan show profiles. This lists out the wired network profiles on the machine, and in this case, shows the profile I added to this package. And lastly, I'll confirm my 3 certificates were installed and to the proper stores by opening up Certificate Manager. For this demo, I added random non-production certificates to this package, which included this root certificate from Fiddler. The intermediate certificate I used is named Surface Demo Kit. And for the client certificate, I added this one called Fred. Okay, so with this, I can confirm our package successfully installed and properly configured the machine using my package's custom configurations. Now let's move on to testing on a physical device to confirm everything works there. And make sure to do this before using your package in a production environment. Now for this example, I wanted to demonstrate how provisioning packages can be used in conjunction with Windows Autopilot. So all I've included in this particular package is the wireless network profile for my Wi-Fi network. And then I'm using a provisioning command to reboot the system. I found that a reboot is needed for Windows to use the wireless network profile. Before we can install our package on a physical machine, I need to copy the .ppkg package file over to the root directory of a USB flash drive. Then insert the drive into a PC that's booted into the initial out-of-box experience. Windows should then automatically detect the package and then begin installing it. And from there, it connects to my wireless network, it'll install day 1 updates, and then kick off Windows Autopilot. And like the package we tested with the virtual machine, this is another use case of how you can use provisioning packages to automate and speed up Windows provisioning. Now, once you start building and testing packages for yourself, you may run into issues getting some of the custom configurations installed or working properly. So let's go over a few things you can do to troubleshoot. In the event your provisioning package fails to install and you can't determine the root cause, I'd recommend isolating each of the package's components into separate provisioning packages. Then work to test installing each of the packages individually. And after you're able to get each component working, you can then combine them back into a single package. If your package is set to Entra ID join the device during UBI and that fails, you may be unable to sign into Windows to further investigate, as there's no local user account to sign into. So for troubleshooting purposes, you could add a local administrator account to the package, which you could then use to sign into Windows and troubleshoot. And once you're logged in, regardless of what you're troubleshooting, you'll find the relevant package installation logging within Windows Event Viewer, where I'd start by looking at the Windows Provisioning Diagnostics provider logs. For network authentication issues, you could spend a lot of time troubleshooting this. My advice would be to engage with your networking team to fully understand the network's requirements and then work with them to build a package that meets the required criteria. Now, to finish this series out, I wanted to share some of my tips and best practices for using provisioning packages. If you reimage Windows machines with a USB drive, you could add your package to the root directory of the bootable USB media. So after Windows finishes installing, initial setup will then detect and automatically install the package. If your package is configured to Entra ID join the device, I'd recommend adding the bulk enrollment token's expiration date to the name of the package, so you'll know the token is still valid before using it. While building a package, make sure to save the Windows Configuration Designer project file, so changes can be made to your packages without having to completely rebuild them. Take advantage of the security settings available when exporting the package, to either add a password or sign it with a certificate, which will help to ensure only authorized people can install the package on a device. To wrap things up, I hope you were able to learn a few things about provisioning packages and how they can be used to fully automate the Windows out-of-box experience. And if you have any questions about provisioning packages or would like to share your thoughts on them, feel free to leave a comment below. Thanks so much for watching. I'll see you in the next one.